We are all acutely aware of the profound transformation digital computers have brought to every corner of our existence. From how we communicate to how we work and even how we think, the impact of digital computers is undeniable. Yet, what if I told you that the arrival of quantum computers could eclipse this revolution by an order of magnitude? The emergence of quantum computing is not just another chapter in the evolution of technology, it could be a seismic shift in the way we understand and interact with reality itself. The implications are so vast, so profound, that they might one day be considered the most transformative event in human history. This leap forward in computation is poised to solve problems once deemed utterly insurmountable, everything from cracking codes that were thought to be unbreakable, to simulating the most complex biological systems with a level of precision we can hardly imagine. But with this immense potential comes an unsettling reality, one that some scientists are beginning to voice with increasing urgency. Quantum computers may not just reshape our world as we know it, they could very well tear it apart at the seams. Their disruptive potential isn't merely a theoretical concern, it's something that could radically alter the very fabric of space, time, and existence. To truly understand why quantum computers hold such transformative, and potentially dangerous, power, we first need to step back and examine what makes them fundamentally different from classical computers. Classical computers, the ones we rely on every day, process information using bits. These bits are simple, binary units of data that are either 0 or 1. But quantum computers operate on a completely different principle. Instead of bits, they use quantum bits, or qubits. What sets qubits apart is their ability to exist in a state of superposition, meaning they can represent both 0 and 1 at the same time. This strange and counterintuitive property allows quantum computers to perform calculations at unimaginable speeds, far surpassing the capabilities of even the most powerful classical supercomputers. But it's not just about speed. It's the remarkable ability of quantum computers to solve problems that involve immense complexity, problems that would take classical computers millennia to solve. Think of equations with trillions of variables interacting simultaneously, something completely beyond the scope of classical systems. Yet beneath this incredible potential lies a darker truth. The very principles that give quantum computers their immense power, superposition, entanglement, and quantum coherence, are also what make them capable of potentially reshaping the very structure of our universe. For centuries, scientists have struggled to fully comprehend the mind-boggling implications of quantum mechanics. At its core, quantum theory suggests that reality is not a fixed and immutable thing. Instead, it exists as a probability, a haze of potential outcomes, until it is observed. Particles do not occupy fixed positions. Instead, they exist in a fluid state, occupying multiple possible states simultaneously, only assuming a definite state when measured. This is where quantum computers come into play. By harnessing this uncertainty, quantum computers don't merely simulate reality, they interact with it on a level that is as deeply profound as it is unsettling. To see why this is such a cause for concern, imagine for a moment the possibility of a quantum computer so powerful that it could simulate the behavior of every particle in the universe. A machine of this scale might have the ability to map out not only the past and present but also the future of all existence. Such a computer could potentially simulate everything that has ever happened, everything that is happening right now, and everything that is destined to occur in the future. But herein lies the great paradox. The very act of simulating reality at such a scale could disrupt the reality it's trying to simulate. To better understand this, think back to one of the most famous thought experiments in quantum mechanics, Schrödinger's cat. In this experiment, a cat locked inside a sealed box is both alive and dead, existing in a state of superposition, until someone opens the box and observes the cat. It is the act of observation that causes the system to collapse into one definite state, alive or dead. On a cosmic scale, a quantum computer, by observing and simulating all the particles of the universe, might behave in a similar way. It could collapse the wave function of reality itself simply by running its calculations. In other words, the mere act of simulating reality could, in theory, change the reality it is attempting to model. This is not just speculative fiction. Recent experiments in the realm of quantum physics, even with small-scale quantum systems, have revealed strange and unexpected results. For instance, researchers simulating black holes found that as their models grew increasingly complex, they began to produce outcomes that couldn't be explained by current laws of physics. It was as though the simulation was somehow interacting with a layer of reality that transcends the system itself. This was a clear sign that, as the complexity of quantum systems increases, the boundary between the simulated and the real begins to blur. So, what happens when quantum computers are no longer operating on small systems but are simulating entire galaxies, or perhaps the multiverse? The implications are staggering and deeply unsettling. Some physicists speculate that such powerful machines could accidentally create feedback loops in reality itself, where the act of simulation alters the very system it is trying to replicate. These feedback loops could ripple outward through time and space, potentially destabilizing the fundamental laws of physics or even unraveling the probabilistic nature of the universe. There are even more extreme speculations that advanced quantum computers could be capable of manipulating the quantum wave function, which is the mathematical representation of all possible states of existence. A sufficiently powerful quantum computer, it is suggested, might be able to edit reality itself. This raises profound ethical and philosophical questions. Who decides what reality should look like? And what happens if these edits go wrong? If quantum computers can alter the fabric of existence, what safeguards do we have to ensure that these changes do not spiral out of control? What's even more chilling is the possibility that we might not even notice these changes. If quantum computers have the ability to alter reality at a fundamental level, these changes could be so instantaneous, so imperceptible, that we wouldn't even realize the universe has been rewritten. In the blink of an eye, our understanding of reality could be fundamentally altered, and we would remain completely unaware of the changes. But the dangers don't end there. Quantum computers also pose a monumental threat to our digital security and privacy. Their ability to break classical encryption methods means that virtually every form of digital security we rely on today could become obsolete. Bank accounts, private data, government secrets, they could all be exposed, vulnerable to anyone with access to a quantum machine. But the consequences of quantum computing could extend far beyond the realm of cybersecurity. These machines could theoretically decrypt the quantum wave function of the universe itself, unlocking hidden layers of reality and granting unprecedented control over the building blocks of the cosmos. The implications of such power in the wrong hands would be unimaginable, opening the door to a new kind of arms race, one in the quantum realm. Governments and corporations are already pouring billions of dollars into the race to develop the most powerful quantum computers, all in pursuit of what is called quantum supremacy, the ability to solve problems that no classical computer ever could. But this frantic rush to dominate the quantum frontier has left many scientists deeply concerned. They worry that the technology is advancing far faster than our understanding of its potential consequences. The real danger lies not just in our ignorance of how quantum computers will interact with reality, it's that we may never fully understand the true nature. Quantum mechanics is inherently probabilistic, meaning that even our most advanced theories can only describe probabilities, not certainties. This makes it almost impossible to predict how quantum systems will behave in complex, real-world scenarios. And yet, despite these uncertainties, the world continues to push forward. The promise of quantum breakthroughs, curing diseases, solving climate change, unlocking the deepest mysteries of the universe, is too compelling to ignore. But at what cost? As quantum computers grow more powerful, they will force us to confront some of the most profound questions in science, philosophy, and ethics. What is reality? Can it be altered? Should it be altered? Some scientists believe that we are on the verge of entering a new era in which humanity will gain unprecedented control over the very fabric of existence. But others fear that this power could spiral out of control, leading to consequences we can scarcely imagine. One thing is clear. Quantum computers represent a force unlike anything humanity has ever encountered. They challenge our understanding of the universe and our place within it. They offer the promise of untold progress, but they also carry with them the specter of unimaginable danger. The real question is not whether quantum computers will reshape reality. The question is whether we are truly prepared for the consequences when they do. Are we ready to harness the power of the quantum realm responsibly, or will we charge ahead, blind to the dangers that lie in wait? Scientists around the world are racing to answer these questions, working tirelessly to understand the true nature of quantum computation and its potential implications. But as they delve deeper into the quantum abyss, they are discovering that the answers may not be as comforting as we hoped. This is a time of great promise and profound peril, a time when the very fabric of reality itself hangs in the balance. As we stand at the precipice of this new quantum revolution, one thing is crystal clear: the world we know will never be the same again. As we venture deeper into the extraordinary potential of quantum computers, we must confront the unsettling realization that these machines do more than calculate, they interact with the very structure of the universe itself. To understand how they might inadvertently, and perhaps even intentionally, rewrite the course of existence, we must delve deeper into the intricate mysteries of quantum entanglement, quantum coherence, and the wave function itself, which form the heart of quantum mechanics. These concepts may sound abstract, but their consequences could be far-reaching, affecting everything from the smallest subatomic particles to the very fabric of space-time. Quantum entanglement, one of the most puzzling phenomena in physics, allows particles to become intrinsically linked, regardless of how far apart they are. A change to one particle instantaneously affects the other. This phenomenon, which Einstein famously described as spooky action at a distance, has now been demonstrated to be a core principle of quantum computation. Imagine if quantum computers were able to entangle trillions, or even quadrillions, of particles simultaneously. Could they create a web of connections so vast that it spans the entire universe? Could this web of entanglement alter the very structure of space-time itself? These are questions we are only beginning to grapple with, and the answers may have far-reaching consequences. As the complexity of quantum systems grows, so too does the challenge of maintaining quantum coherence, the ability of qubits to remain in superposition and exist in multiple states simultaneously. This fragile state requires isolation from environmental noise, but what if that noise is not just a hindrance but a potential doorway to unintended consequences? Could a quantum computer so powerful that it influences not just its environment but the quantum state of particles across the universe create a phenomenon akin to quantum echoes? These ripples could disrupt molecular structures, alter subatomic particles, or even create temporary rifts in space-time itself. It is a thrilling and terrifying thought. A quantum computer capable of interacting with reality on such a vast